So this problem wants us to find an equation of the tangent line to the graph f of x equals 2 sine of x plus the cosine of 2x at that point, and then determine all the values of x where the interval from 0 to 2 pi at which the x has which the graph has a horizontal tangent. Okay, so what are we going to do? We're going to take the derivative. So find the equation of the tangent line. So to write the equation of a line, we need two things. We need a slope and we need a point. We have the point because they give it to us. The point is pi comma 1. So now we just need to find the slope. So to find the slope, we're just going to take the derivative. So 2, derivative of sine is cosine. And then plus, so now cosine of 2x. So that's chain rule. The outside function is cosine. So the derivative of cosine is negative sine. The inside stays the same, but then multiply by 2. Because the derivative of 2x is 2. So that's the slope. So then we just have to find the slope at pi. So 2 cosine of pi minus 2 the sine of 2 pi. Well, the cosine of pi is negative 1. So this is negative 2. And the sine of 2 pi is 0. So this is just negative 2. So the slope is negative 2. X coordinate is pi. So x minus pi equals y minus 1. Just by using point slope form. And that's got to be it. I mean, that's pretty beautiful. Let's take a gander at Desmos and see if that works out. So to do this, I like to look at the whole graph. Oh, you know what we should do? We should find all the places where it has a horizontal tangent first, before we look at the graph. I have a category on chess. Ugh. Thank you. I'm so used to autosave. I type in all the changes I want to make and then I don't click done. You said that and I was like, what? No, I don't. I very specifically even talked about changing it. Because I typed it and I changed it. I didn't hit done. Oh, we're also in the middle of recording a video. So let's get going then. So what were we doing now? We needed to find all of the horizontal tangents. So we needed to say horizontal, that's when the slope is equal to 0. So we'll go 0 equals 2 cosine of x minus 2 sine of 2x. Whoa, that's not obvious how that's going to work out. Well, maybe it is. Because we're going to add to the other side and divide by 2. So we're just going to get that cosine of x equals the sine of 2x. Oh, maybe that's not so obvious. So then if I have the sine of 2x, are they making me go cosine of x equals 2 sine x cosine x? And then, right, I can't divide by cosine x. I've got to subtract cosine x and then factor out. Oh, wow, that was huge, actually. That was exactly what I needed to do. Because now I have this. So we've got when that equals 0, and go ahead and solve for sine of x when that equals 1/2. So when is the cosine 0? At pi over 2 and 3 pi over 2. When is the sine of x 1/2? This is going to be a lot. At was 30 degrees, the small one. So pi over 6, and then all students. So 5 pi over 6. All right. So this should be quite a long video with a nice little mess up in the middle, but that is just going to have to be fine. So what is this? I didn't even type this in right. So 2 cosine of x. No. What is the function? It is 2 sine of x. That's the derivative. The function is 2 sine of x plus the cosine of 2x. Oh gosh. Getting a friggin' like Windows error. And it's still there. There we go. So there's our graph. That's looking good. Just a few sine waves hanging out. And so what did we want to say? Well, first off, we wanted to say that in between 0 and like 6, there's these 4 places that it's horizontal. At pi over 6, and then this will be pi over 2, 5 pi over 6. That's 5 pi over 6. Oh, right. This is 5 pi over 2. And then 5 pi over 6. And then 3 pi over 2. Very nice. And then that goes into the next section. And then we calculated the tangent line. So let's go ahead and graph that because that's always pretty to see. Negative 2 times x minus pi equals y minus 1. And there we go. We see how beautifully that's tangent. Just intersects at that one singular point. And there we go. So that's all the chain rule. That was some good chain rule practice. We learned the chain rule. We showed some good examples of how it can be used. And we just used it to take a bunch of derivatives. So now that's a new tool that we have in our toolbox.